In this video, we're going to talk about the key characteristics of a quadratic function from its graph. So a quadratic function is a function of degree 2. Standard form of a quadratic function is f of x equals ax squared plus bx plus c. Vertex form of a quadratic function is y equals a times x minus h squared plus k. The graph of a quadratic function is called a parabola, and parabolas have several key characteristics. So one very important characteristic that we've discussed is the domain and range. So remember, the domain is all possible x values of a function. Well, every parabola includes all possible values of x, so we would say that the domain is all real numbers. Remember when we write that in interval notation, that looks like negative infinity, comma, positive infinity. Remember we put the open parentheses at both endpoints because infinity is an idea, not a number, so we can't include it in our interval. The range will have one endpoint, and that'll depend on whether the parabola opens up or opens down. If it opens up, it's going to go from that specific endpoint all the way up to positive infinity. So you can see in this first parabola, we have a range that goes from 0 to positive infinity. If the parabola opens down, it's going to go all the way from negative infinity up to that whatever endpoint. So in this case, we have an endpoint of -1, so it goes from negative infinity to -1. So we also talk about the vertex of a parabola. Remember, depending on whether the parabola opens up or opens down, this vertex will either be a minimum or a maximum. So for a parabola that opens up, like this first parabola here, you can see that the vertex at 4, 0 is a minimum because it's the lowest point on the parabola. The vertex of this parabola in the second image here is going to be a maximum because this parabola opens down. So -3, -1, the vertex is going to be the highest point on the parabola. So we can also talk about the axis of symmetry. The axis of symmetry is a vertical line. So since it's a vertical line, it's going to have an x equals equation, right? Remember from Hoy-Vux, that's how we write the equation of a vertical line. It's also going to pass through the vertex. So the nice thing about the axis of symmetry is that if you find the vertex, the x-coordinate of the vertex will actually tell you the equation of the axis of symmetry. So for example, if we have the vertex at 4, 0, the axis of symmetry is going to be x equals 4. Here we have the vertex at -3, -1, so that x-coordinate tells me the equation of the axis of symmetry, which is x equals -3. The reason we're interested in the axis of symmetry is because your parabola has reflectional symmetry with respect to the axis of symmetry. So if you imagine this axis of symmetry like a line that we could fold our parabola across, notice that both sides of these parabolas are going to match up. So we also know that parabolas can sometimes have a y-intercept. The y-intercept will be the point at which the parabola crosses the y-axis. Remember that when the parabola crosses the y-axis at the y-intercept, that point will have an x value of 0. So that's why the y-intercept has the form 0y. So for example, this parabola here has a y-intercept at 0, 6. So we also have x-intercepts of a parabola, and those are the points at which the graph crosses the x-axis. At the x-intercept, the y value will be 0, so x-intercepts will have the form x comma 0. And so we have three different possibilities when we're talking about x-intercepts of parabolas. Some parabolas have one x-intercept, like this first image here. You can see it has an x-intercept at 4, 0, which also happens to be the vertex. Some parabolas have two x-intercepts. So like this parabola here, you can see crosses the x-axis at -3, 0 and 2, 0. And then some parabolas will have no x-intercepts. So you can see this parabola right here, it kind of looks like it's hovering above the x-axis. So it's actually never going to cross the x-axis. So parabolas can have one x-intercept, two x-intercepts, or no x-intercepts. So the x-intercepts are connected to the roots and zeros of the quadratic equation. The x-coordinate of the x-intercepts can help us identify the roots and zeros. Roots are found by setting f of x equal to 0 and solving for x. So for example, in this first parabola here, if I take this equation f of x equals x minus 4 squared and rewrite it as 0 equals x minus 4 squared and solve for x, I would find that x equals 4. Zeros are values of x that make the equation f of x equal to 0. So in this second parabola, if I took f of x equals x squared plus x minus 6, and if I plugged in -3, I would find that equation equals 0. I would get the same result if I plugged in 2, I would find that f of x equals 0. So here's a summary of the key characteristics all in this diagram here. So when we're looking at a parabola, we want to first find the vertex, and then remember the axis of symmetry will pass through the vertex. Wherever the graph crosses the x-axis, we'll have an x-intercept, and wherever the graph crosses the y-axis, we'll have a y-intercept. So let's practice with some examples now. Let's graph f of x equals x squared plus 2x minus 15 and identify key features. So I'm going to go to Desmos and I'm going to type in this equation, x squared plus 2x minus 15. Okay, so now you can see we have the graph of our function. Notice that the domain includes all real numbers for x. So I'm going to describe the domain as going from negative infinity to positive infinity. So the range has a specific starting point, right? You can see if I zoom out that the lowest value of y is going to be here at negative 16. Then it includes all y values above that. So the range is going to start off at negative 16, right? So I have a closed bracket because it includes that point, and then it's going to go to positive infinity. So the vertex you can see here is that lowest point on my parabola, and if I click on it in Desmos, it gives me the coordinates. So the vertex will be at -1, -16, and then that means my axis of symmetry is going to pass through that point, right? So remember the x coordinate tells me the axis of symmetry, so it's going to be x equals -1. And if you want to check that, you can actually just type that into Desmos and see that it does in fact cut your graph into half. The x-intercepts, I can just click on them. And when I click on them, I will see the coordinates. So this has x-intercepts at -5, 0, and at 3, 0. Okay, so this parabola has two x-intercepts. And the y-intercept, I can also click on that. That's going to be at 0, -15. So now you can go ahead and pause the video and try doing this example on your own. So to solve this problem, you're going to start off by graphing it in Desmos. When we look at the graph of this function, notice that the domain will include all real numbers for x, so it'll go from negative infinity to positive infinity. The range, well, the lowest value is down here somewhere and it goes on forever. So the range is going to start off at negative infinity, but then it's going to go up to this highest y value, which is at positive 25. So the range is going to go from negative infinity to positive 25. When I clicked on that point, you can see that it's the vertex at -325. The axis of symmetry will pass through the vertex, so the axis of symmetry will be x equals -3. Remember, you can also double check this by graphing it on your function. If you want to turn this into a dotted line, you can just click the edit list and then click on that button, and it'll allow you to turn it into a dotted line. So then let's look at the other features. We have the x-intercepts. If we click on them on the x-axis, those will be at -8, 0, and 2, 0. The y-intercept, if we click on that point where it intersects the y-axis, we have 0, 16. So quadratic functions have several important key features that we can identify by graphing the equation.